So, welcome everyone. So, in this lecture, we were going to discuss further more about the pure rolling motion. So, till now, that we were in a previous video, we were discussing about a scenario. In this scenario, we discussed that if there is a body, and let's suppose this is a surface, and here the friction coefficient is mu, and if I given it a velocity v, then after which after what time the body will start pure rolling. So in a previous video we discuss it in a verbally we discuss it, and today we will discuss it in this is a polythene. Okay guys, not a word. So so let's suppose if this is the center mass have velocity v, then this point also will move with velocity v. And since here is a relative motion, so there should be a friction force that will oppose this relative motion. And this friction is kinetic, and this value is if here the mg will act in downward direction. So normal equals to mg, and friction we know that mu n, so friction from here equals to mu mg, and that will remain constant because it is a kinetic friction. So let's suppose this friction, what will do, the friction will do, the friction reduce its linear velocity and also increase its angular velocity, because this friction force will provide a torque to this body. Let's suppose this is an disk. Okay, so now we have to find that after what time this body start pure rolling motion. So what we have to do, we have to do simple. First we have to write down the equation for the translation motion. So here in translation motion there is no force in forward direction, but there is a force friction that will decrease its linear velocity. So friction equals to minus ma. So from here friction is mu mg, so mu mg equals to minus of ma. From here acceleration equals to minus ka mu g. Okay, now second equation, we have to write down the equation for the torque. So here only friction force is providing it a torque. So friction force is providing a torque in this direction, that means clockwise direction. So let's suppose the clockwise direction is a positive direction, because we need a torque in clockwise direction, because when this body will rotate in clockwise direction, then there will be a tangential velocity, and that is equals to r omega. So we know the pure rolling v is r equals to r omega. So this friction force increase omega and decrease this, and at a time t this condition holds true. So when this condition holds true, then we can say that at this time the body starts pure rolling. So for a friction, torque equals to, we know torque equals to I alpha, and we also know torque equals to r cross f. And since r is in this direction, f is this, and r cross f is also in clockwise direction. So this is our perpendicular, so we can write down rf equals to I for disk equals to mr square by 2, and alpha, if alpha, this is alpha. Okay, now r f equals to mu mg equals to m r square by 2 and alpha. From where r is cancelled out, m is cancelled out, and alpha equals to 2 mu g by r. So this is the angular acceleration. Now we need two things. First one is velocity at time t when the body starts rolling. Second one, we need omega, angular velocity at after time t. What is the angular velocity? So at time t we can write down as, first we have to rub this. So let's suppose, okay, so we need, so what we have a equals to minus mu g and alpha equals to 2 mu g by r. We have two values. Okay, now we, since force, there is only one force and that is constant, so acceleration is constant, so Newton's equations are valid. So we can write down v equals to u plus at, and v equals to final velocity, that is equals to v, and u initial velocity is v. Let's suppose this is v naught. So v naught alpha a equals to minus mu g. So minus mu g t. This is the first equation. And second, for angular v naught omega final equals to omega initial plus alpha t. So omega final is omega, and initially there is no omega because initially it have only translation velocity. So this is 0, and plus alpha equals to we have find 2 mu g by r and also t. So omega equals to 2 mu g t by r. Now we have omega and we have velocity, so put it in this equation. So from here v naught minus v equals to mu gt equals to r, multiply it r, so r will cancel out, so that is equals to 2 mu gt. So eliminate, so write down this equation in this side. So this is minus mu gt, if it come here, then it will plus mu gt, and 2 mu gt and 1 mu gt equals to 3 mu gt equals to v naught, and from here t equals to v naught upon 3 mu g. So this is the time after which the body starts pure rolling motion. So that's all for today. If you are here till now, then like and subscribe this channel, and then we will meet in next video. Till then, goodbye. Okay.